It's Sunday, May 7th, 2017, and we're about to listen to and watch Neil deGrasse Tyson on Fareed Zakaria Morning's show and a discussion of the universe and the repeating patterns that give you an overall view of how science happens. And it's important for the way we're going to understand, as Michio Kaku says, the mystery of the universe and the mind as the greatest challenge of the 21st century. Let's take a listen.
Do you ever look up at the myriad stars on a clear night and wonder how they got here? Ever wonder how big the universe really is or how it all began? Well, wonder no more. My next guest is probably the world's most famous and favorite scientist. Neil deGrasse Tyson has a new book out called Astrophysics for People in a Hurry. This is great for us because television is always in a hurry. Neil, welcome back to the show.
Thanks, Fareed. Always good to be on your show.
So you begin with the Big Bang. You actually begin before the Big Bang.
Yeah, the name of the first chapter is In the Beginning. When else would you begin such a story? That's right. The Big Bang is the first sentence. Just takes you there.
What I'm struck by is that the Big Bang really also is the beginning of physics, chemistry, and biology in the way you explain it. So First what happens is you have this tiny dot, as it were, and it explodes.
Yes.
Right? And out of that, explain what happens.
Yeah, so there's still some unknown elements of this chapter, very earliest chapter in the history of the universe. But what's intriguing is how, as the universe expands, certain laws of physics take shape and other laws of physics begin to manifest. And so some of the great challenges of early universe cosmologists is untangling what happened when. And this allows you to imagine other universes. This is where the concept of a multiverse comes in. Other universes where the laws of physics took a slightly different turn earlier in the universe, and you get a whole other kind of bubble, some other kind of somebody else's Big Bang that may have laws of physics that might not be favorable to life itself.
So you also talk about in the Big Bang how it sort of is the beginning of chemistry in a way, because these particles start to interact with one another. And I've always thought that you make a very good case for people to understand how interesting chemistry is. Chemistry is often the place where you lose people in science, right? It's organic chemistry that just seems too hard.
Well, I love me some chemistry. And so you get chemistry when you have atoms, because atoms come together to make, of course, molecules. But before you have an atom, you have to make the particles that make the atom. So you got to back up to get those particles, the quarks, then the protons, neutrons, electrons. You got to make those first. Then they come together and you make your base ingredients, hydrogen and helium. Then stars pick up the mantle. And so I give a whole chapter in there to the periodic table of elements, something I think should be one of the greatest icons of our culture. Because think about it. When I think of a kitchen and you want to bake a cake, you need the ingredients, the flour, the sugar. You want to bake the universe or stuff in the universe, start with your ingredients. The periodic table has the 92 elements, hydrogen through uranium, out of which everything is made.
Out of the Big Bang, the next stage, as you say, comes biology, because those chemical interactions somehow produce something that we now call life.
Exactly. So biology is the most complex form of chemistry we know. And it's there, but here's the catch. In a separate chapter titled On Earth as It Is in the Heavens, the chemistry and physics on Earth repeats everywhere in the universe. These elements are on the moon, on the sun, on other galaxies. And so we're not made of special ingredients. We're made of the same ingredients. To some people that's depressing, but to me that's enlightening. You're the same as the universe.
And do you think there's life outside of
once you look at the numbers and the carbon, we're carbon-based life, because you can make tremendously complex molecules stringing together carbon atoms, such as our DNA. Carbon's everywhere in the universe. And you look at the latest planet tally, we're rising through 3,000 planets nearby relative to the size of the galaxy. The universe has been around for 13 billion years. Once you look at these numbers, there's no excuse thinking that we're the only life on Earth. That would be some ego talking if that's how you said it. It's anyone who studied the problem recognizes the very high likelihood it would be somewhere, though we haven't found it yet, but we've got top people working on it.
Why do you think we don't teach science well enough to hold people's attention?
You know, that's a great question. I think science, as well as many other subjects in school, K through 12, let's take, is I think we're thinking that children are empty vessels, and you unzip the head, pour in the knowledge, zip it back up, slap a diploma on them and send them off, and then they're declared to be educated. And somewhere we're missing, as a minimum, a course not on chemistry, biology, physics, or geology, but a course on what science is as an enterprise, and how and why it works, and how it drives curiosity and inquiry. Have that as a minimum, but on top of that, teach things like analysis and interpretation, and how to coalesce bits and pieces of information into new coherent ideas. Then when you come out and you're declared a graduate and some new information rises up, you don't say, oh, I didn't know that was true. You would say, let me find out whether or not that is true. And then you become a lifelong learner.
So when we look at something like global warming, how should we think about it? There are people who say, look, of course it's just a theory. All of science is a theory. These are hypotheses. And, we should be looking at it. There are other scientists who say, no, it is at this point a fact.
If anyone utters the words, it's just a theory, it means they're missing a piece of their education where they do not fully understand what science is and how and why it works. So I try not to beat folks over the head in power, because they're duly elected by a population that wants their leadership to serve them. And I recognize that. That's the system we've all bought into. So as an educator, I look at the electorate and I say, if you're going to make an informed decision, not only about the country's future, but especially about your own future, it would be greatly enhanced by just learning how knowledge is acquired and how it is affirmed in the scientific arena. And today you have people who will just accept what anyone tells them, or think that they can deny an objectively established scientific truth. And then I don't mind that if in a free country, think what you want. But if you now rise to power and have have jurisdiction over legislation, and you pivot that on what you don't know about how the world works, that's a recipe for disaster. I would say it's the beginning of the unraveling of an informed democracy.
We are always lucky to have you on.
Fareed, always good to be here.
Astrophysics for people in a hurry. Neil deGrasse Tyson.
Thank you.
Pleasure. Next on.
So, this is a very powerful conversation with Fareed Zakaria and Neil deGrasse Tyson about the enterprise of science and the whole process of learning and discovery and problem solving, and the role of human beings in using their knowledge of science and the tools that come from creativity to make life worth living. And that's what we're trying to do with our invention of a new way of imagining your own mind, not as a periodic table of elements, but let's call it a framework, a periodic framework of concepts that shows the process of concepts, the categories of concepts, the hierarchies and organization of concepts in a three-dimensional, virtual, augmented reality, mixed reality world to give a far fuller understanding of our place as human beings on Earth in a universe or maybe a multi-universe, but to give a much bigger idea of who we are and why we all can prosper and live together in more harmony than we